This is the third problem that I did for you guys. Okay, so here we go. Take your derivatives. Set your derivatives equal to 0. And if you'll notice, you got x equals plus or minus the square root of 5, and then y equals plus or minus 1. And I said you could group it in these various ways. Okay, so this is going to be a very long proof because we have to go, classification rather, because we have to classify point A, point B, point C, and point D. And I'm going to take my time with that. All right, so let me get the d-test down so that I can use that consistently. So what do I need? fxx. So let's just go to f sub x right there. Pay attention to the x, 2x, fyy. Let's go to f sub y right here. Pay attention to the y, so negative 12y. And then fxy. So let's go back to f sub x here. Pay attention to the x's, there aren't any. And pay attention to the y, sorry. Pay attention to the y's, there's no y's in there. And fyx. So let's go here, right? And pay attention to the x's. There's no x's in here, so this is equal to 0. So as expected, those bottom two are equivalent to each other. All right, so that means that the d-test equals fxx times fyy minus fxy times fyx. So all of the second derivatives. So d is equal to 2x times negative 12y minus 0 times 0. Okay, so I'm going to leave this here because I want to be able to use this for my various points. All right, so here's the 4 points. You got to be keeping that in mind. I'm going to do them one at a time. So let's deal with the point A, which is the square root of 5, 1, and then its corresponding z term. So we go over here and we apply that to, apply it in the d. So d equals, notice now I have an x and a y to plug in, so d of, rather the square root of 5, comma 1 equals, so I have 2 times the square root of 5 times negative 12 times 1 minus 0 times 0, right? So I'm actually making a substitution into this d. All right, so let me see if I can come up with that number. 2 square root of 5 and from this I got negative 53.67. All right, let me get my set of criteria, because if you look, d's negative. Look, d is a negative point, a negative value rather. So I'm done. Look what it says. If d at your critical point comes up negative, then your point is the saddle point. So we go up here and we say this is a saddle point. Done. That's the point A. All right, let's keep going. So I'll remind you of the points that we're dealing with. There we go. So check, this is a saddle point. Okay, the second one says that we need to check the point B, which is the square root of 5, negative 1, and then the z value that's associated with that. Okay, so here we go. We got to plug this into the d. So d of the square root of 5, comma negative 1, then equals 2 times the square root of 5 times negative 12 times negative 1 minus 0 times 0. All right, so let me see what I get. Times okay, so this equals positive 53.67. Make sure you're checking my work. Okay, so let's see what the test tells us. And according to the test, when we applied the D to our point, we ended up with a positive value. So let's see, we've seen this before. If D comes up positive, keep going. So it says that you guys need to go right here, right? I'll show it to you right here, fxx. So we want to try to plug our point back into fxx, like that. So this equals 2 times the square root of 5, because square root of 5 is what you have in x. Okay, so be very, very clear that now you can make a substitution because your fxx is 2 times the x, right? So we don't have anywhere for the, we actually have a place for the square root of 5, and it's right there. So if I take 2 times the square root of 5, I get positive 4.47. So let's see what the rules say. If D is positive, fxx is also positive, we're looking at a local minimum. So this is a local min. So we go over here and we say, here we go, got distracted. Here, this is a local min. All right, let's keep going. We did A and B, now we need to get to C. Okay, unfortunately for you guys, you do have to do all of this work. Let me remind you, let me put this here. Let me tell you what the point C is. C is negative square root of 5, comma, positive 1, comma, star, star, star. Right, of course, this comes from going back to your original equation. Okay, so there's C. Okay, so we're going to plug this into the D formula. So D is at the negative square root of 5, comma 1, then equals 2 times negative square root of 5 times negative 12 times positive 1. So this would equal positive 53.67. Okay, so if that's the case, according to the rules, if D is positive, keep going to fxx. So we're going to go up here. Here's fxx right here, right? So fxx equals 2 times x. If that is the case, then fxx at negative the square root of 5, comma 1, this equals 2 times negative square root of 5, which equals negative 4.47. So let me think about that. The D is positive, but the fxx is negative. So according to your rules, if D is positive and fxx is negative, you're looking at a local maximum. So this is a local max, right? So let us go back to our list so that we can classify that one. So this one right here is a local max. One more problem, one more point, and then we're done, right? So I probably shouldn't have called it point B. It might be a bit confusing with that description. But let's get to it. So then the point D is right there. Okay, I'm going to write that down for you. So D of negative square root of 5, comma, negative 1. Okay, so we're going to plug that into this. Let me just call it E. Okay, I don't want you to get confused. Let's call this one E. Right? So at the point E, of course, you have 1, 2, 3, 4. Okay, please find that last coordinate by going back to your original function. So D at negative square root of 5, negative 1, then equals, I'm going to go right in here. This is 2 times negative square root of 5 times negative 12 times negative 1. This equals negative 53.67. Let's see, make sure. Positive, negative, negative, negative. Okay. So if you'll notice, that puts me in a situation where D's negative. again. So I should be looking at saddle point. Right here. Like that, and you're done.